Hi everyone, I'm Abhinav. I work as a solutions architect and my job in plain terms is to take AI from whiteboard to production. I just don't design systems. I am the person who has to answer the call when they break, and trust me, they do break. What I'm sharing today isn't theory, it's scar tissue. I've spent a significant chunk of my recent life building a multi-agent AI system for one of the most unforgiving real-time environments I've worked in, a telecom radio access network. Near streaming data, 9 specialized agents, and orchestrated that had to run root cause analysis, data analytics, and simulation simultaneously. The first version worked beautifully in the demo and it broke in production in 5 very specific, very painful ways. This talk is about those 5 failures, not the theory of those agents, the actual production war stories, and the architectural decisions that turned each one around. My thesis: agents are non-deterministic systems running in deterministic infrastructure, right? Most teams don't realize what that means until they are in production, staring at a wrong answer with no idea how the system got there. Let me paint the picture of what we were building, right? Telecom radio access network. The part of the mobile network that connects your phone to a cell tower. Thousands of network elements, all generating data continuously. Performance metrics, alarms, configuration states, fault tickets, near streaming all the time. The ask was to build an agentic system that can do three things simultaneously: root cause analysis, when something breaks, identify why, data analytics, surface patterns, anomalies, and trends, and simulation, model the impact of a proposed change before you apply it to a live network. Right? We designed a system of one orchestrator at the top, 9 specialized sub-agents, each owning a data domain. Like we had network and inventory, physical network, hardware age, maintenance and status, like fault tickets with historical incidents and resolution data, performance KPIs with live and historical cell metrics data, configs with current and historical configuration state data, alarm correlation with taking 50,000 alarms per hour and finding the signal, RF optimization with antenna tilt, power levels, coverage, topology and neighbors agent with cell relationships and handover chains, chain management data with every config pushed correlated against configuration windows, right? Traffic and demand, subscriber load, busy hour and congestion. Every data was near streaming, 9 specialized agents, n number of data domains, real production, not a POC. Now, before I get into the 5 patterns, right, I need to establish something foundational because if you don't understand this, the patterns won't land. Right? Agents are not a smarter API call. They are a different class of system. In traditional system, the failure is loud. 500 error, stack trace, alert fires. You know what break, where and when. You can write a test that asserts correct behavior, right? In an agent system, failure is quiet. The system returned HTTP 200, the JSON is well formed, the answer is wrong. Nothing threw an exception, right? The model made a judgment call that seemed statistically reasonable given its context, and that judgment was wrong. Behavior is probabilistic. Same input, different output. You cannot unit test a judgment. You cannot assert that a reasoning step will produce a specific result. And the blast radius in a traditional system, a bug has a natural containment boundary, right? In an agent with tool accesses, a single wrong decision can touch 5 downstream systems before anything stops it. Here is the standard agent stack, right? System prompt defines the role, user sends a query, LLM reasons, decides to call a tool. If the task isn't done, loop. In a demo with a curated query set and the control tools, this is elegant. Then production happens. Real data, real users, real edge cases. Right? We have like 5 failure modes for those, and these aren't hypothetical. Every one of these happened in our system in the order you'd least expect, and none of them were caused by the model. These are 5 patterns we'll talk about. 1. The autonomy trap. You gave the agent too much trust and no guardrails. It made a decision that seemed reasonable, the consequences were not. Second, the silent failure. The agent failed, you have no idea why, no trace of the reasoning, no ability to defend the conclusion to anyone asking hard questions. Then we have the context flood. A single tool call returned 51,000 records. The model hallucinated a summary. This is a tool design failure. Again, not a model failure. Then we have the eval illusion. You can't improve what you can't measure. You have been making changes and hoping. Then we have the topology collapse. At 9 agents, it worked. At 30 plus, it collapsed. Flat orchestration has a scale ceiling. Nobody tells you unless you hit it. Let's talk about them. Pattern 1, the autonomy trap. This failure looks like success. The system ran, completed, returned the response. The network engineer saw no RCA found and escalated to manual investigation. 2 hours later, a senior RF engineer found a neighbor relation that had been misconfigured during a routine parameter push 6 hours ago before the degradation. The change management agent had that information. The topology agent could have confirmed the impact. Neither was ever called. The orchestrator saw degraded throughput, elevated latency, and router to performance KPI. The routing decision was logical, it was wrong. And nothing in the system asked, are you sure? Have you considered other explanations? Right. This isn't a telco problem. This is a problem for any agent with unconstrained routing authority. The general pattern is agent commits to the most probable explanation and pursues it, right? Exactly like a junior engineer who's convinced themselves of an answer before they've checked all the data. Except the junior engineer can be asked, did you check X? The agent cannot. Confidence gated routing, the first solution architecture, confidence gated routing, right? Below 0.75 confidence, spawn parallel sub-agents, synthesize across results. This sounds expensive, but in practice, it just takes me 4 seconds, and we have got 3 wrong single path routings in the first week. Then we have the blast radius classification. Read only, reversible, and irreversible. The agent's authority is proportional to the certainty of its reasoning. Fast on clear signals, cautious on ambiguous ones, never autonomous on irreversible actions. Simulation mode for the highest stake decisions. See the outcomes before you commit. Right? Let's have a look at the architecture. We have orchestrator at the top. Every routing decision passes through a confidence gate. Above 0.75, single path. Below, parallel dispatch, and the result synthesized across agents. Right? Blast radius classification. Every tool call is tagged at a design time. Read only, fire and forget. Reversible, logged, irreversible, human gate, no exceptions. The principle here is the agent authority proportional to reasoning certainty, not a blanket trust grant. Then we have the second pattern, the silent failure. This one is specifically brutal in expert domains, right? And telecoms is a domain full of experts. Senior network engineer, 15 years building intuition about their network. They look at the RC output and their gut says it's wrong. They asked me to show the reasoning. I couldn't. I had the final answer and nothing else. They were right. It was a transport issue. The RCA was wrong, and I had no trace of how the system reached its wrong conclusion. Again, the pattern is not specific to telecoms, healthcare, finance, legal, any domain. But the end users are domain experts. They will not trust a system that gives an answer without evidence, and they shouldn't. The correct answer is not enough. The defensible answer is what you need, right? Let's look at the solution patterns. Agent, trace, log. Every reasoning step is a structured event, not just logs. Structured, queryable, time-stamped events that can reconstruct the full reasoning chain after the fact. Then we have reasoning receipt. Attached to every output human readable, right? Shows the exact chain, which agents were consulted, which tools ran, what evidence was dominant, and critically, what evidence was dissenting. Let's look at the dissenting flag. If the hardware signal was 0.62 and the transport signal was, let's just say, 0.68, the output should say both, not just the winner, runner up to, with its confidence. That's what a good analyst would do. Your agent should do the same. Looking at architectural pattern for the same. If we look, every step in the reasoning chain is a logged structured event, timestamp agent, tool, inputs, outputs, latency, everything, right? If we look at the bottom left, we have left broad trace, queryable, auditable, reconstructible. If we look at the bottom right, the reasoning receipt attached to the output, human readable, shows the primary signal, the confidence score, and the dissenting signal with a pointer to where it appeared in the trace, right? The last line, if you look right, hardware point 62 step 3 is what changes the relationship between the system and the expert. They can now go look at step 3, they can challenge it, they can trust it, or override it with the context system didn't have. Show your work. Moving on, pattern 3, the context flood. The most purely engineering pattern of the five and the most underestimated one. Our alarm correlation agent had a tool called getAlarms. Parameters, cell ID, time window. Simple, clean. The orchestrator is running an RC on a degraded cell and it calls getAlarms with a 24-hour window. Return 51,000 events. That's a real number from a busy cell in a dense urban network. 51,000 events. Context window 80% saturated before a single alarm was processed. What did the agent do? It hallucinated a summary. Pattern matched against the most common alarm types from training. The actual root cause, a specific low severity alarm repeating 94 times in a narrow 6-hour window, was invisible. The tool had no output size contract. One line of missing design destroyed the reasoning. The pattern appears everywhere. Healthcare, a tool returning a full patient history when the agent needed the last three lab values. Finance, a market data tool returning tick by tick history for a 2-year period. Legal, a document retrieval tool returning full case files. The common thread, unbounded output plus finite context window is equals to hallucination. Let's look at the solution architecture for the same. Number one, output contracts, maximum output size, right? Default summarization strategy and pagination token if you need more. Semantic compression, the tool does the work of ranking and filtering before handling the data to the model. Don't give the model 51,000 events and ask it to find the pattern. Give it top 5 clusters. Unambiguous interfaces, names as scoped verbs, descriptions written for the model as consumer. Test each tool description by asking the agent to choose between it and a similar tool before you ship. Let's have a look at the diagram. Right before, like, there were no contracts, ambiguous names, unbounded outputs, right? If you look at the right, we have scoped verbs, explicit size limit, semantic compression built in, right? The principle here is that tools are APIs for an AI consumer. Your consumer is brilliant at reasoning and terrible at resolving ambiguity. Design the interface for the consumer you actually have, not the one you wish you had, right? Pattern 4, the eval illusion. Let me ask you something direct, right? If I told you your agent's accuracy dropped 15% last week, would you know? Could you prove it? If your answer is will notice because users would complain, this is not a measurement framework, that is just hoping, right? In telecoms, correct is contested. We had post incident reviews where the RF team, the core team, and the RAN team will all wrote different root causes for the same incident. They were all partially right. What do you label that in your eval data set? This is the hardest version of the eval problem, and it's not unique to telecoms. Healthcare has it, legal has it, financial advisory has it. Any domain where the answer depends on expertise and perspective has this problem, right? Even setting aside disputed ground truth, static evals decay. Your network changes, your agents change. The 50 golden examples you built last year quarter reflects a system that no longer exists. Let's have a look at the solution architecture for these scenarios. Expert feedback loop, 15 seconds structured attached to the network natural flow, right? Not a survey. The person who acted on the output, who knows whether it was right, rates is part of closing the ticket. This creates a continuously updated data sets that's always current. Living dataset, version tagged. It decays gracefully. Old examples are weighted less, new examples are weighted more. The ground truth evolves with the system. Regression gate. Any changes triggers a regression run. More than 5% drop on any val category blocks the deploy. The gate doesn't care if you think the change was an improvement. Prove it. Right? Let's look at a continuous evaluation framework. Right? The continuous evaluation flywheel, agent outputs, network engineer acts on it, rates it in 15 seconds as part of closing the workflow. Structured feedback feeds the living data set, right? Automated eval runs, score the system, improvements feed back into the agent, right? The regression, if you look at the regression gate, any change triggers an automated run, accuracy drops over 5% blocks the deploy. Nothing ships without a measurement pass. You cannot improve what you cannot measure. And with agents, measurement is the only way to know your system is healthy. Right. Let's have a look at the 5 pattern. The last pattern, and this one is specifically what happens when you succeed pattern. System works, stakeholders are happy, they want more, you scale it, it breaks, right? When we went from 9 agents to 24, the orchestrator's routing accuracy started degrading. At 30, it was hallucinating agent selection. Fault ticket code is going to the RF, optimization agent, config code is going to the traffic demand agent, follow-up question getting picked up by completely different domain agents, and the one that started the conversation, right? The orchestrator couldn't hold the full decision surface in context. A flat list of 30 agents is too many choices for a single LLM reasoning step to navigate reliably, right? Now, this is not a telco problem, this is a scale problem. Any multi-agent system with flat orchestration will hit this wall at somewhere between 10 and 20 agents, depending on the complexity of the decision surface. And the wall isn't gradual. The routing accuracy drops non-literally linearly as you add more agents to the threshold. Right, let's have a look at the solution architecture. Hierarchical grouping, domain clusters with group leaders. The orchestrator sees 4 group leaders, not 30 agents. The decision surface shrinks to a manageable size. Session lease pattern. Once an agent owns a task, the orchestrator is blocked out until the agent explicitly releases it. No mid-session rerouting, conversation coherence by design itself. Agent self-reported release. The agent signals completion. The orchestrator doesn't decide. This removes the most common source of rerouting errors. The orchestrator deciding a task is done before the agent is finished. Right, let's have a look at the diagram. Left depicts a flat topology, one orchestrator, direct connections to every agent, works at 9, routing accuracy degrades past 20, hallucinates at 30. At right, we are seeing hierarchical topology, orchestrator sees 2 group leaders. Each group leader manages its own domain agents, the decision surface at the top stays small and manageable, right? Session lease pattern. The moment an agent takes ownership of a task, the orchestrator is locked out until the agent explicitly releases it. No more mid-session rerouting, conversation coherence guaranteed. Scale the system, not the problem. Right? Let me bring this all together. 5 patterns, 5 architectural decisions, 1 common thread. Autonomy must be earned, not granted just because the model is capable, right? Confidence gates, blast radius classification, simulation mode before irreversible action. The agent's authority is proportional to the certainty of its reasoning. Agents must show their work, non-negotiable in expert domains. trace log, reasoning receipt, dissent flagging. If you can't defend the conclusion, you can't earn the trust. Tools are the agent's reality. The agent only knows what its tools tells it. Bad interfaces corrupt reasoning before inference begins. Design tools like APIs for an irrational consumer. Measurement is not optional. You cannot improve what you cannot measure. Expert feedback loops, living data sets, regression gates. Nothing ships without a measurement pass. Topology is an architecture. How you arrange agents matter more than which agents you use. Flat topology breaks at scale, not gradually, suddenly. Hierarchy scales, session leases preserve coherence. Agents are non-deterministic teams. Design them like one. The same principle that makes human teams work, right? Clear roles, bounded authority, accountability mechanisms, feedback loops are exactly what make agent system survive production. And the model, I ran this architecture with three different models, right? From like Claude to GPT models to open source models. The five patterns appear with all the three. Different model, same architectural failures because the failures are not in the model. They are in the confidence gates that you didn't build, the traces you didn't log, the tools you didn't design carefully enough, the events you didn't write, the topology you didn't think until it collapsed.